Algebra 2, practice test. Okay, this is the test this week. So if you go to 105, 1.05, it has a practice test. And when you go there and go to page 2, you see a link where you can click and get the practice test. So I'm going to take that test and I'm going to work the problems here. Now, I will tell you, when you click on that, it gives you the 15 problems. It also gives you the answers, and it gives you the solutions on how to get the answers. But I'm going to work this live here on video so you can review this. And it maybe if you're reading the solutions that doesn't make sense, hopefully this will help you above that. So skip forward to whichever problems you're confused on and see if you can't have this straight before you take the test. All right, let's look at this. So there's 15 problems, just a few pages here. So we're going to start on number 1. It says, what is the first step to solving this system right here by eliminating the y variable first? So the y variable. So we want to get rid of the y's. Well, the first step then, we have to make those y's the same number but opposite signs, which means we need to multiply this one by 2 and multiply the second one by 5. So it'd be the first step would be to multiply the first equation by 2, which is this number, and multiply the second one by 5, which is that one. So when we do that, this would be negative 10y, and 5 times the 2 would make it a positive 10y. See, and they would cancel each other out when we add those. So that would be the first step. Question 2. If you were to use the substitution method, to solve the following system, write the new equation after the expression equivalent to y from the first equation is substituted. So we're going to substitute the first one into the second one, which means we need to make this one where it is a y equals, so we can substitute it. We need to know what y equals. So if we have this, 8x minus y equals negative 9. All right, so we would need to move the x to the other side. Move 8x. So that means negative y equals negative 8x minus 9. Okay, that's not y equals, that's negative y equals, right? So we need to multiply everything by negative 1. So that would be y equals 8x plus 9. So the new equation would be, since that's what y equals, it would be 4x minus 3. And instead of y, we're going to substitute 8x plus 9 equal negative 22. That would be the answer it's looking for. That is the new equation. All right, so that is the answer right there. We had to convert that to a y equals so we can substitute in for what y equals. Okay, this one I'm going to have some extra paper for because this next one's going to require us to work this out. Connor went to New York for a vacation. He spent 3 nights at a hotel and rented a car for 4 days. All right, so let me see. 3 nights and rented a car for 4 days. Jillian stayed at the same hotel, but she spent 4 nights and rented a car for 5 days from the same company. So if Connor paid $675 and she paid $875, how much did 1 night at the hotel cost? So we have nights at the hotel and we have renting a car for a day. So we're going to let X equal the hotel cost and Y equals renting the car cost. All right, so that's our 2 different variables. And we need to figure out our equation. So Connor spent 3 nights. That's 3 hotel nights. So 3x. And rented a car for 4 days. So plus 4y's. All right. And how much did he spend? $675. So there is the equation that represents Connor. Jillian stayed at the same hotel 4 nights, 4x, and 5 days, 5y's, and she spent $875. All right, it wants to know how much is the hotel night. So we're needing to find the x. What does the x equal? Okay, so we need to solve this systems of equation. We can do it by elimination or by substitution. So it's probably just easiest to do elimination right here rather than substitution. So let's try to make these, let's try to make these y's go away because we're trying to solve for x anyway. So we need them to be the same number, and we need one to be positive and one to be negative. So I'm going to take the first one, and I'm going to multiply it by, I'm going to make it a -5 because they're both positive. I want one of them to be a negative. And the other one, I'll multiply both sides by the 4. So I'm taking the 5 and multiply the top one and the 4 and the bottom one. I'm making one of them negative, so that way it'll go away. So -5 times everything up there. So it'll be -15x, all right? -5 times 3x. And then this will be -20y. And then this is 675 times -5. So that's going to be -3,375 because that's 675 times -5. All right, and then we've got this one we have to multiply by 4. So 4 times 4x is 16x. 4 times 5y is a positive 20y. And here we have 875 times 4. Well, 4 times 875 is a positive number, and it is 3,500. 4 times 875, 3,500. So now we add these together. Oh, this is working out really nicely. -15x plus 16x is just x. These go away, so we already have our x equals -3375 plus 3,500 is 125. So that is what one night at the hotel cost, $125. There's our answer. 125. All right, next. 3 teachers are taking their classes to the movies. Ooh, what class is this? We want to sign up for that one, right? They each have students, parents, and chaperones in the group. So Mrs. Russell brought 21 people to the movies. Mr. Dodger has twice as many students, twice as many parents, and the same number of chaperones as Miss Russell. Ms. Kuhn brought 3 times as many chaperones as Miss Russell, but the same number of students and parents as Mrs. Russell did. So this is like one of those word puzzles, right? If Mr. Dodger brought 56 people and Ms. Kuhn brought 40 people, write a system of equations to represent the people all 3 teachers brought to the movie. So we don't have to solve this. We just have to write it. So they're comparing everyone up here to Miss Russell, right? And she brought 21 people. So let's write this. Miss Russell brought 21 people. So she brought, we're going to say students is X. Let me write this. Students will be X. And the parents will be Y. And then chaperones will be Z. Okay, so Miss Russell brought 21 people as just students, parents, chaperones. It didn't say twice as much or 3 times. She's the one they compared it to. So her students plus her parents plus her chaperones equaled 21 people. Okay, this is Miss Russell's equation. So now let's look at Mr. Dodger. He has twice as many students. So he has 2 times X because it's comparing him to Mrs. Russell. Twice as many parents. So he has 2 times as many parents and the same number of chaperones. So Z. And he had Mr. Dodger about 56 people. Okay, so there's 2 of our equations. Now the third one, Ms. Kuhn brought 3 times as many chaperones, but the same number of students and parents as Miss Russell. So students and parents, X plus Y plus, she said 3 times as many chaperones. So 3Z for a total of 40 people. And that's it. That's our system of equations. X plus Y plus Z equals 21. 2X plus 2Y plus Z equals 56. X plus Y plus 3Z equals 40. It doesn't ask us to solve it, but if we needed to solve that, we could start with that and do that. But we have to be able to write the system before we can solve anything. Okay, graph the following systems of equations. All right, so to graph this, and we can do that on Desmos, or you could do it on just paper, but to graph this is both in standard form, right? We don't know how to graph standard form. It doesn't tell us anything. We don't know the y-intercept. We don't know the slope. We don't know anything. So we need to convert these to where they are y equals mx plus b, all right? Because we can graph y equals mx plus b, because that is the slope and that's the y-intercept. So let's convert these. So 4x plus 2y equals negative 2. Move the 4x to the other side because x is on the other side from the y. So we have 2y equals negative 4x minus 2. Now we need to divide by 2 to get y by itself, because that's what we're trying to get, y by itself. Y equals negative 4x divided by 2 is negative 2x, and negative 2 divided by 2 is negative 1. So that is one of our equations. The other one is x minus 3y equals 24. Let's move the x over. So we have negative 3y equals negative x minus, plus, that's a positive 24, plus 24. So we're going to divide by the negative 3 to get the y by itself. So we're going to divide everything over here. So this is y equals negative 1x divided by negative 3. It's just a 1/3 x, right? Because 1 over 3. And it's positive because negative divided by a negative. We have a positive 24 divided by a negative 3. So that is negative 8. So when we graph those, we can just use Desmos. And we can just enter those right here. Y equals 2x minus 1. Oh, I'm sorry, that's a minus 2x. Negative slope. And the other one is y equals 1/3 x minus 8. Okay, there it is. So we graph those. And so now we know what the solution is to the system of equations. It's 3, negative 7, because it gave, with the graph, we can find the solution. But it didn't really ask for the solution. It asked us to graph those. All right, let's move on. That's question 5. We're 1/3 of the way through. Okay, this says, how can x plus 4 equals 3x plus 12 be set up as a system of equations? Well, these are two linear functions that are set equal to each other. We can also write a linear function is f of x equals x plus 4. That's one of the functions, right? And the other one is f of x equal 3x plus 12. That's the other function. And to set them up with system equations, we just write this as a y. So y equals x plus 4, y equals 3x plus 12. Y equals y. Right? If they're both equal to y, we can set them equal to each other. So going backwards substitution, we substitute y in for here. See, y equals x plus 4, so we substitute right there. Going backwards, we can go back to the y equals. So this is how we set it up. That's the answer. System of equations right there. All right. Write a single equation that the graph of the system's equations solves. Single equation. Okay, so that would be something like this, right? A single equation. So let's see, what is this one first? Let's look at this line that goes down. So the y-intercept is at negative 1. So our b is negative 1. And what is our slope? Our slope, we'll see, it goes through this point, it goes through that point, it goes through that point, it goes through that point. So our rise over run, the rise goes down 2, so negative 2, and the run is 1. So negative 2 over 1. So our slope is negative 2. So one side of our equation would be negative 2x minus 1, which is this line here, equals, because that would be equal right there, this line right here. This has a y-intercept of positive 4, And it has a slope of, let's see, it goes through that point and then goes through that point and that point and that point. So the rise is 1, 2, 3, and the run is 1. So the slope is 3 over 1, which is the same as just 3, right? So it equals 3x plus 4. There it is, a single equation. Negative 2x minus 1 equals 3x plus 4. Fabulous. All right. Write the system equation that matches the following graph in standard form. All right. Standard form is the ax plus by. I'll get my hand out of the way where you can see that. Equals c. So you have the x and the y on the same side with the constant on the other side. So first, again, we got to write the equation of the line. So this one has a y-intercept of -1, and the slope goes from there. The next point is there. So -1, -1, and then the run is 1, 2, 3, 4, 5. So this has a slope of -1/5 for this line here. So that would be y equals -1/5 x minus 1. That is this line here. That's not in standard form, but I got to have the line to start with. So let's do the other one over here. -5 is our y-intercept, and our slope equals, let's see, we go through this point and then all the way to here for our next point. So it goes a rise of 1, 2, 3. So the rise over the run, and the run goes 1, 2, 3, 4, 5. So this has a slope of 3/5. So this equation is 3/5 x minus 5. Minus 5. So there's our two equations, but we need them in standard form. So they want the system equation in standard forms, which means the a and the x and the y. I'm sorry, ax plus by. The x and the y. The x and the y have to be on the same side. So let's add 1/5 x to both sides, and so this would be 1/5 x plus y equals -1. 1/5 x plus y, that's on this side of the equation. Those cancel out. -1 is the only thing left on the other side. The other one, we need to subtract 3/5 x from the y. So on this side, we got -3/5 x plus the y equals -5. So we put those one right underneath the other one. And that's our system of equations. System of equations in standard form. System of equations in standard form, right there. If you don't like the fractions, we can also multiply everything by 5, since there's a 5 on the bottom. And that, becomes just x, because 1/5 times 5 is 1, plus 5y equals -5. And we can multiply everything here by 5, because 5 is the bottom of our fraction. And that becomes -3x plus 5y equals -25. These are the same equations. They will graph the same lines. So you can do it whichever way you feel comfortable with. Whichever way you feel comfortable with. So it is the same. All right. And if you don't like the starting out with a -x, you can multiply everything by -1, make that a positive 3x minus a 5y equals a positive 25. That's the same as that. That still graphs the same line. So you can play with the signs and all that, but this is perfectly acceptable with the first answer we got. Write the system equation that matches the following graph in standard form. So that's like this, but it's standard form. All right, so this has -4 as our y-intercept. And the slope of, let's see, it goes, the next point it goes through, looks like it's right there. So it goes 1, 2, 3, 1, 2. So it's 3 rise, 2 run, slope of 3/2. The second line has -5 as a y-intercept, and the slope on that goes 1, 2, 3, 1, 2. It goes to that point next. So it also has a slope of 3/2, which we can tell it has the same slope. They're parallel. When we solve the system equations, this is going to be no solution because there's no point where those are the same. These are not the same anywhere. But we can set it up in standard form. Y equals 3/2 x minus 4. And y equals 3/2 x minus 5. So when we move the x over, it becomes negative 3/2 x plus y equals negative 4. Or again, you can multiply everything by 2 if you don't like leaving a fraction. Negative 3/2 x plus y equals negative 5. So that's this one, right? So in standard form, we do that. Or for you folks that don't like that, multiply everything by 2. You got negative 3x plus 2y equals negative 8. And negative 3x plus 2y equals negative 10. Or again, you can multiply these by negative 1 if you don't like the x's to be negative. Some people don't like the x's to be negative. But that is the answer to number 9. In a few different forms. Again, you have multiple options on how you want to give that answer. Okay, number 10. 2 car rental companies have different rental plans. Sands Car Rental charges $50 a day and 10 cents a mile. All right, so let's get these going. $50 a day, 10 cents a mile. And that's for Sands. And then Beach charges $60 a day and no per mile charge. So how many days would the trip need to be to make the cost equal if the total was 300 miles? The trip total was 300 miles. All right, so we're going to need our paper on this one. We're going to need to give us some room so we can work that because this is going to take a little bit of work. So let's set up our 2 equations. So let's see if we make X be daily cost and the Y be the cost per mile. So you could use D and M if you want. You can use whichever variable, but X and Y is what we're used to seeing. So we'll use X and Y, the day cost and the mile. So we set up 2 equations. So for the first one, the cost would be for sand. I'm going to use S, sand. Is how much a dollar? 50x, $50 a day, and then 10 cents. So that's 0.1. 0.1. It's not a 1. 1 would be $1. 10 cents for every mile. So the 50x plus 0.1 y. And then the other one, Beaches, charges 60x and 0 per mile, right? So 0y, we don't have to write that because it's a 0y. So if it equals 300 miles, right? So we want to know how many miles, how many days would the trip need to be to make the cost equal. So if these are equal, 50x plus 0.1 y equals 60x. If they were equal to each other, if it was 300 miles. So miles is y. So if 50x plus 0.1 times 300 equals 60x. Okay. Solve this for x now because we're trying to figure out how many days. It says how many days, trying to solve for x, would the trip need to be to where it would cost you the same for either company. So 50x plus 0.1 times 300 is 30 equals 60x. We'll subtract 50x since the x's are on the other side already. And the constants on this side, we'll move everything to the right. So 30 equals 10x, right? So divide by 10. If the trip was 3 days, it would cost you the same for either company. Either company would be exactly the same. 3 days would make the cost the same either way. This would be $180. That'd be $180. So if it's less than 3 days and you're going to spend 300 miles, then you'd have to see which company would help you more. But 3 days is where it's the same. So 3 is our answer. All right, Bob is analyzing two linear functions, f of x and g of x. We have the graph of f of x. We have a table for g of x. It's kind of small, but this is, let me write it where you can see a little bigger. -2 and 4, -1 and 1, and 0 and -2. So this is the x, and this is g of x, which is the same as y, right? G of x, same as y. Okay, will they intersect? And if so, what is the coordinates of their intersection? Okay, very good question. So let's see. Just looking at the table, if we graph that, -2, 4, -2, 4 is right here. So let me get a different color here. We'll put that. -1, 1, -1, 1. Oh, look right there. And 0, -2 would be right here. So if we graph that, we don't have to draw the line. We already know where they intersect because this point is actually on that line. So the coordinates of their intersection is at -1, 1. Otherwise, I could draw the line, see where they connect, but it's right there. All we have to do is look at the points, and one of the points is right there on the graph. That one was easy because they were nice to us and gave us a point that was right there. Okay, what are the x coordinates of the solutions to this system? So we have to solve that system. Let me turn and get some more paper here. We just need the x. We don't need to know the whole xy point. We just need the x. So let's start out by writing our equation over here. And we have y equals x minus 6. Since we already have a y equals, one of our equations is already y equals. That just says substitution is probably our best choice. So let's go x squared plus, and we'll substitute x minus 6 for the y. See that? I took this y, x minus 6, and I substituted it right there. So we got x minus 6 squared. So now let's solve this for x. X squared plus, what's x minus 6 times x minus 6? So x minus 6 times x minus 6. Okay, well, remember, when we multiply, we have to distribute to everything inside the parentheses, and then this -6 also has to distribute. Since we have two things being multiplied by the other parentheses, we have to distribute everything. So this is x times x is x squared. X times -6 is -6x. This -6x is -6x again. And -6 times -6 is a positive 36 equals 36. Okay, let's simplify like terms. We have 2x squared. And then this is minus 12x because it's minus 6x minus another 6x. And then we have plus 36 equals 36. So if we subtract 36 from both sides, we have 2x squared minus 12x equals 0. We have to set it equal to 0 to solve it. And in this case, our constant went away. We have no constant at all. So we can factor this because we need the factors that are equal to 0, because one of the factors has to be a 0 for that to be 0, right? So this is an easier one to factor. We got a 2. We can pull a 2 out of both sides. So 2, and there's an x in both terms. So if we pull out a 2x, what would we have to multiply 2x by to get back to that? Just an x. And 2 times what is -12? 2 times -6, and we pulled that x out. So these are the factors. If we multiply these back together, we should end up back where we started, right? If we properly factored it, we multiply those, we'll get back to there. So that means either 2x equals 0 or x minus 6 equals 0. There's two different solutions here. If either one of these is 0, then that's going to be true. So divide by 2. So if x equals 0, it's true. Or if x equals 6. So these are the two solutions. So what are the x coordinates of the solutions? X equals 0 and x equals 6. That is the two solutions to this equation right there. All right, this wants us to write the system equation that matches the following graph. Well, this is the equation of a circle. So we have x squared plus y squared equals the radius squared. That's what goes over here. What's the radius? The radius is from the center. 1, 2, 3. This is a geometry. We already had geometry. So 1, 2, 3 is the radius. All right. R equals 3. Since the radius is 3, that means this is 3 squared or 9. So that's one of the equations. The other one is linear. That looks like it crosses the B is at 3. And what is the slope? It goes from here to there to there. So it goes up 1 over 1, up 1 over 1, up 1 over 1. So the slope is 1 over 1. So this is y equals x plus 3. That's that line right there. Slope of 1, so just x. Y-intercept 3. There is the systems of equations that they're looking for to solve that right there. Okay, we're down to our last two problems. Okay, Neil is analyzing a circle right here and a linear function. Will they intersect? Well, let's look at the points. 1, which would be right there, 3. Okay, there's one of the points. It's just outside the circle. Where's the second one going? 2, 5. That's going to be up here. And then 3, 7 is going to be even higher. Will they intersect? It doesn't even ask us where. It just says, will they? Well, if we look at those points, if we connected those, yeah, there's not much question. They're going to intersect. Yes. Yes. You put those on the graph, 1, 3, and just 1, 3. The first 2 points could tell that the line is going to run right down into the circle. All right. You could look at this, figure out the slope. As this goes up 1, that goes up 2. All right. So the slope, 2 and 1, the slope is 2 over 1. All right. And you can take this backwards 1. This goes every 2. So if we had 0, if we added that to the table with backwards 1, that means this would be 1. So the y-intercept is 1. So the y equals 2x plus 1. You could graph that. But just knowing that the y-intercept is 1, that's inside the circle. The y-intercept's right there at 1. And there's a point outside. It's going to cut through the circle. Just knowing that there's a point inside the circle means you know it's going to intersect the circle. So don't make that harder than it is. It's a pretty simple one. Okay, last question. When planting his crops, Farmer Tim knows his 7 acres can support peas and carrots, and he wants to make $7,000. So he can make $2,000 an acre for peas, which is the variable P. So they're giving us the variables. $2,000 an acre for peas and $1,000 an acre for carrots. What equation would be a constraint in his system of equations? A constraint. Okay, so let's see. $7,000 is what he can make from his crops. So how big is his farm? His farm is 7 acres. 7 acres. So the constraint, because he can make $2,000 per acre, but the constraint is the acres. That's the total he can plant. Right? How much money he makes? He wants to make $7,000. That's not a constraint. That's what he wants. He's limited to 7 acres total. So his peas plus his carrots have to equal 7 acres. That equation would be the one that's the constraint. The other equation would be 2,000, because that's how much dollars he makes for each acre of peas, and 1,000 for each acre of carrots. He wants it to be $7,000, but that's not a constraint. That's how much money he makes of it. He's constrained to the total area he has, right? Because it cannot change. The amount of money he makes change. He could make more than $7,000 if he planted more peas and less carrots, right? That can change, right? So he can change that, but constraints means it can't change. That's all we have. So 7 acres is it. He can't plant any more than 7 acres, period. So think about the word constraint. That means it's a limit. You cannot do anything outside of that. So that is the equation. Of the two equations, this is the one that's the constraint. So that is it. Remember, when you can print this out, you can look at this. It does have all the solutions in the lesson there. When you get to printing that out, it's got all the answers. It's got one page. It's just, I don't know where I had the page here somewhere, but one page is just the answers. But then it scroll down farther, and then it has all the solutions on how they work it. Now, I may have worked it differently, so there's more than one way to solve math problems most of the time, guys. But if you have questions on this, please let me know before you take the test, and do work you can be proud of.
Let's get out of here. Word to your multiples.
Math, baby. We're learning math, baby.